Bismillahirrahmanirrahim. Welcome students in this video. Uh, Today our topic name is Laplace transformation, which is the same which we have learned in our last week lectures. This is our lecture number 22. In this lecture we try to solve some application regarding Laplace transform. So here we start with exercise 4.1. First 10 questions we solved in our previous lecture. Now we start with question number 11. Here f of t is equal to e raised to the power t plus 7, and by definition of Laplace we know that Laplace of f of t is equal to from 0 to infinity e raised to the power minus st f of t dt. Now we substitute here the value of f of t, which is e raised to the power t plus 7. Here I substitute. You see Laplace e raised to the power t plus 7 from 0 to infinity e raised to the power minus st, and the value of f of t, this is e raised to the power t plus 7 dt. Now in this step I use the exponential property. Here I write it as e raised to the power t plus 7 as e raised to the power t into e raised to the power 7, and you know that when bases are same, powers add. It is a property of exponential functions. So in this way, here you see that e raised to the power 7, e raised to the power 7 is a constant term. So we take this outside the integral, and then from 0 to infinity e raised to the power, and on the remaining part we apply the property of exponentials, and we write it as e raised to the power minus into s minus 1 into t dt. When we take Laplace, when we take integral of this exponential function, we get e raised to the power minus into s minus 1 into t divided by minus into s minus 1 from 0 to infinity. Here you see that I take this negative s into s minus 1 outside, and it is written as minus e raised to the power 7 over s minus 1, and this part is written in this form from 0 to infinity. And in the next step I apply the limits, or evaluate the function at the given limits. So it is written as 1 over e raised to the power s minus 1 into infinity, then negative sign 1 over e raised to the power s minus 1 into 0, and you know that e raised to the power infinity is equal to infinity, and e raised to the power 0 is equal to this is e raised to the power 0, and you know that 1 over infinity is equal to 0, 1 over infinity is equal to 0, and you know that e raised to the power 0 is equal to 1. So minus 1 over 1 is equal to minus 1, and we multiply this, you get e raised to the power 7 over s minus 1. This is our required answer. Here we apply the previous rules that we described, how Laplace act on exponential function, how Laplace treat with the trigonometric functions, and how Laplace treat with the constants and the hyperbolic functions. Here we see all application regarding these rules. Here question number 16. Here we have a function which is a product of trigonometric function and exponential function. Again, by using the definition of Laplace, and here I am writing its formula, and then you see here I substitute the value of f of t here, and writing it as from 0 to infinity e raised to the power minus st e raised to the power t cos t dt. Here I substitute the value of cos of t in the form of identity, which is called the Euler's identity, e raised to the power iota t plus e raised to the minus iota t divided by 2. The reason of this is that in this form our question becomes very easy to solve. That's why we are using its identity, which is in exponential form. And so you see here e raised to the power minus st into e raised to the power t e raised to the power iota t plus e raised to the power minus iota t divided by 2, and then we multiply these two with this term and then with this term. So it is equal to and I take 2 outside from the integral. It becomes e raised to power minus st, e raised to power t into e raised to power iota t plus e raised to power minus st, e raised to power t, and then e raised to power minus iota t. Again, by using the property of exponentials, I am writing the above as it is. Then I am writing it as 1 over 2 from 0 to infinity e raised to power minus, take common negative and t, minus t common, then remaining is s minus 1 minus iota. Then when we take negative and t common, it becomes s minus 1 plus iota. When I take integrals of these two, we get the following results as it is, as these are shown here. Then I take this minus 1 over s minus 1 minus iota outside and apply the limits on this value. Similarly, I take this outside and on the remaining part I apply the limits as you see here. On simplification, you know that this part becomes 0 and its answer is negative 1, and similarly the answer of this part is 0 and this is negative 1. So I am writing in a short form that minus 1 over s minus 1 minus iota into minus 1 over s minus 1 plus iota into minus 1. When I multiply these and I get 1 over s minus 1 minus iota plus 1 over s minus 1 plus iota. When I take LCM of this, we get s minus iota plus s minus 1 plus iota plus s minus 1 minus iota divided by s minus 1 whole square minus iota square. On simplification, we get 1 over 2 into 2s minus 2 over s minus 1 whole square plus 1. When I take 2 common, that 2 cancel with this 2, and our required answer is s minus 1 over s minus 1 whole square plus iota. This is also called our first transformation, first type of transformation. And when we move further in our topics, then we see such type of applications in Laplace. Now question number 13, f of t is equal to t e raised to the power 4t by definition of Laplace, and here is formula. Then I substitute the value of the function here, and again I use the property of exponentials here and write it as. So here you see that e raised to the power here we have two functions, one is exponential and one is algebraic here. So by applying by parts formula, here t e raised to the power minus s minus 4 into t divided by minus into s minus 4 from 0 to infinity minus e raised to the minus into s minus 4 into t divided by minus into s minus 4 into 1 dt. Here you see, here you know that what is its answer? It becomes 0, and its proof I have given you in the last lectures. So its value becomes 0 plus 1 over s minus 4. When I take this s minus 4 outside, it becomes positive 1 over s minus 4, and then from 0 to infinity e raised to power minus into s minus 4 into t dt. When I take its integral, it gets this shape, and when I check the given answer at the required limits, it is written as minus 1 over s minus 4 whole square into 1 over e raised to the power s minus 4 into t from 0 to infinity. When I substitute the limits, I get this part becomes 0 and this is equal to negative 1. So it is equal to 1 over s minus 4 whole square. These are a few questions that I have taken that I think these are a little bit tough for you because you are in the initial stages to handle how Laplace transform we perform. So I try my best to choose those questions which are it seems that these are little bit difficult for you. So in this way you are able to solve from 11 to 18 questions, and in case of any difficulty then you will ask me. Now we see question from 19 to 36. Here I take question number 19. Here the function is f of t is equal to 2t raised to the power 4. And again, by using definition of Laplace, you know that very well. Now I substitute the value of f of t here, that is 2t raised to the power 4 is equal to, from 0 to infinity, e raised to the minus st 2 into t raised to the power 4. And this is then I take this 2 outside because it is constant. So it's the remaining is from 0 to infinity, e raised to the power minus st t raised to the power 4 dt. And we know that Laplace of t raised to the power n is equal to n factorial over s raised to the power n plus 1. Here you see that here we have the value of t, the power of t is 4. It means at the place of n we have 4. When I substitute at the place of n 4, I get 2 into 4 factorial over s raised to power 4 plus 1. Because it is called the Laplace of t raised to the power 4. It is called the Laplace of t raised to the power 4. In this way we get 2 into 4 factorial mean 24 divided by s raised to the power 5. When you simplify this, you get 48 over s raised to the power 5. Now question number 23. F of t is equal to t square plus 6t minus 3. By definition of Laplace, Laplace of f of t is equal to, from 0 to infinity, e raised to power minus st f of t dt. From 0 to infinity, e raised to power minus st t square plus 6t minus 3 dt. Now I multiply this exponential function with each term. You see here, from 0 to infinity, e raised to power minus st into t square. Then 6 is constant. Then I take from 0 to infinity, e raised to power minus st into t dt. And the remaining is minus 3 from 0 to infinity, e raised to power minus st into 1 dt. And you know very well that the Laplace of t raised to the power n is equal to n factorial over s raised to the power n plus 1. Here you see that this is, what is this? This is called the Laplace of t square. This is called the Laplace of t square. Here n is equal to 2. Here n is equal to 2. You substitute at this place the value of n is 2. You get 2 factorial divided by s raised to the power 2 plus 1, as I am doing here. Here the power or the value of n is 1. You clearly see here. So you write at the place of n, you write 1 factorial over s raised to power 1 plus 1 minus. Here I write it as t raised to the power 0. So the value of n is 0. The value of n is 0. So you write it as minus 3 into 0 factorial over s raised to power 0 plus 1. And when you simplify this, you get 2 factorial over s raised to power 3 plus 6 over s raised to the power 2 minus 3 over s. In this way, it is our required answer. If you want to simplify more, it is up to you. Then we see question number 27. F of t is equal to 1 plus e raised to the power 4t. Here you see here, again using the definition of Laplace, and then writing the value of the function here, 1 plus e raised to power 4t. When I multiply this e raised to power minus st inside, I get e raised to power minus st plus e raised to power minus st into e raised to power 4t. Split the integral. Split the integral from 0 to infinity, e raised to power minus st dt plus from 0 to infinity, e raised to power minus into s minus 4 into t dt. When I integrate this, I get the following, and on simplification, you see here that is equal to minus 1 over s into 1 over e raised to power s into infinity minus 1 over s e raised to power s into 0 minus 1 over s minus 4 into 1 over e raised to power s minus 4 into infinity minus 1 over e raised to power s minus 4 into 0. Here you see that minus 1 over s, 1 over infinity minus 1 over 1 minus 1 over s minus 4, 1 over infinity minus 1 over 1. On simplification, you get 1 over s plus 1 over s minus 4, and on taking LCM, we get the answer 2s minus 4 over s into s minus 4. In each question, why I am doing complete steps, it is for you that you understand it completely. Then there is nowhere problem for you, that you when you solve your question, it becomes very easy to see inside at every step what is the next step comes after this. That's why I'm doing each and every step, each and everything in each step. So now we see question number 33, f of t is equal to sine hyperbolic kt. Again, using the definition of Laplace, we see here, and you also know that what is the value of what is the identity of sine hyperbolic kt, that is equal to e raised per kt minus e raised per minus kt over 2. This value of sine hyperbolic kt I substitute here and then multiply e raised per minus st with each term. Here you see that e raised per minus st into e raised per kt minus e raised per minus st into e raised to the power minus kt. Again, using the properties of exponent, I am writing it as, and then taking its integral, we get the following. So 1 over 2 into minus 1 over s minus k into 1 over e raised per s minus k into infinity minus 1 over e raised per s minus k into 0 plus 1 over s plus k into 1 over e raised per s plus k into infinity minus 1 over e raised per s plus k into 0. 1 over 2. Here you see that again I using the rules, steps here, that 1 over infinity is equal to e raised per infinity is equal to infinity here, e raised per 0 is equal to 1, and same as here. When I simplify this, I get 1 over 2, 1 over s minus k minus 1 over s plus k. So when I simplify this, I get 1 over 2 into 2k over s square minus k square. It is equal to k over s square minus k square. I hope this lecture you will understand in a better manner. In the last week lectures, I announced that your test will be held in this week. Unfortunately, your lecture will not be conducted online. Inshallah Ta'ala, in this week I try my best to take your lecture online and tell you the different problems. In this week, another our task is that we also conduct an online what I say that is your online quiz. That is in a test format. That is in this way that you are familiar how to take your online test. As you see, in case of COVID-19, our vacations extends up to 15 July. That's why it is very difficult for us to conduct your papers, and the university management decided how to take your papers. So we find a source through which we conduct your online paper. So in this way, I try my best to understand with that technology, with that technique. So in this way, I conduct your test. Inshallah, we will meet with the next lecture. Take care. Allah Hafiz.